right, good morning. Today we're going to get started on section 5.2, and this is going to be one of the more difficult sections that we talk through. To get to the difficult stuff, though, we need to first do some review. And the topic that we're going to be reviewing for a decent amount of time on this video is the topic of summations. Now, you've seen these a couple of times in the past. We talked through summations in Algebra 2, and we talked through summations in pre-calc, so I hope it looks vaguely familiar to everybody. The symbol, the notation that we're going to be seeing over and over and over, is going to be using the capital Greek letter sigma, which is the following. All right, and when we see this symbol anywhere in math, science, or business, this means that we're going to add. We're going to be adding things up. And to get to the difficult material for this section, we need to do a decent, pretty deep review on summations. So let me get you started with a relatively easy summation problem to kind of get it back in everybody's head how it works. So again, the Greek letter sigma, I'll actually write it out. Greek letter, this is the capital or uppercase Greek letter sigma. And what we do below is we identify what variable is going to be in our formula. So in this first example, I'm going to say our variable will be x. And then what we do is we attach the first value that's going to go into our formula. Okay? Now, whatever the heck the formula is, that's normally attached either just to the side or in parentheses. We'll just make this one nice and easy, so we'll make this one 3x minus 1. And what that means is the first number that goes in is 1. So everywhere we see an x, we just simply put in 1 and then add, remembering that sigma means add, so we're going to be adding. Adding what? Well, on the top of the sigma, we identify what the last number is that goes into our formula. So the lower number is 1. The upper number is 4, which means the first number that goes into our formula is 1, and then we use every integer until we get to the top. So this would then mean, since we've now put in a 1, we would then next put in a 2 plus, because we're doing a sum. Then we'd put in a 3, and then if I scooch my screen over a little bit, the last number we're going to put in is a 4. So we continue to add, putting in the numbers 1, 2, 3, and 4. And what you would normally be responsible for is the arithmetic using the formula for each of those numbers. So 3 times 1 minus 1, 3 times 2 minus 1, 3 times 3 minus 1, and 3 times 4 minus 1. And then adding results, so 2 plus 5 plus 8 plus 11 gets me, I believe, 26. If you guys want to double check me, feel free. But I believe we get a 26 there. Okay, so that's a summation. I'm just going to bop through a few examples. If you really remember this well, you could probably skip ahead a little bit. Just keep kind of an eye on where I'm at. The variable that we use absolutely doesn't matter. Many times we use the variable I. So as an example here, this would be the summation from I equals 3 to 5. And the formula might be something simple like 2i squared. All right, the bottom number, let me choose my highlighter tool again. The number on the bottom of the summation tells us the first one that goes in, and the number on the top tells us where to stop. So this means start with the number 3. Start by putting in the number 3, then adding, put in the number 4, adding, and finally put in the number 5. So we started by putting in a 3, then we put in a 4, and finally we put in a 5. So 3, 4, and 5. We start at the bottom number, we finish at the top number. Again, what's expected out of you guys is to do the arithmetic. 3 squared times 2, 4 squared times 2, and 5 squared times 2. So we get 18, 30, and 50. And when we add those up, I believe that adds up to 100. Okay? These problems are not restricted to positive numbers. We can also input negative numbers, so let's just try a simple one. Again, changing up the variable. This time I'm going to use an m and ask you to go from -2 to +2. And the formula this time will be something relatively easy. We'll just go with something like 2m plus 1. And so the number on the bottom is the first one that goes in, the number on the top is the last one goes in, and we use every integer in between inclusively. So that means we'll start with a -2 plus, because we're doing a summation. Then the next biggest number is -1 plus. Then the next number is 0 plus. Then the next number is 1. And finally, the last number that goes in is 2. So we've put in a -2, a -1, a 0, a 1, and a 2. And again, what you'd normally be expected to do is multiply 2 times -2 and add 1. So there we get -3. 2 times -1 plus 1, we get -1. 2 times 0 plus 1, we get +1. 2 times 1 plus 1, we get 3. And 2 times 2 plus 1, we'd get 5. And when we do the addition, I believe, if I'm doing that okay in my head, we just get a 5. Okay. We can have a couple of tricky ones that will be applicable later. Here's one kind of tricky one. If the number we use is an R, and we start with a 2 and end with a 2, and our formula is just something simple like 4R. Okay. The question is, what do we do when the bottom number and the top number are the same? And that just simply means that's the only number that we put in. There's no addition actually to do, because the only number that goes into our formula then is 2, and the result then in this case would be 8. Okay, that doesn't come up too often, just in one circumstance. The one that comes up very often is a problem like the following. If we have the summation from a equals 1 to 6 of 7. Okay, how do you find that summation? Well, the idea is the first number that's supposed to go in is a 1. The last number that goes in is a 6, but goes in for what? What variable are we supposed to be looking for? We're supposed to be looking for an a. And of course, the issue that everybody sees is there's no doggone a in that formula. So I'm going to ask it anyway. Everywhere you see an a, put in 1. What do you get out? 7, because there's no place to put in an a. Next number you'd put in is a 2. Everywhere you see an a, put in 2. What are you going to get out? 7. Everywhere you see an a, put in 3. Put in 4. Put in 5. Put in 6. And again, since there's no a, you just continue to get 7 out as a result. So what we end up with is we put in 1, 2, 3, 4, 5, and 6, and we just continue to get out 7s. And when we add all those together, we get a sum of 42. All right, so that one actually, believe it or not, comes up fairly often when we're summing a constant, right? No variable, so this thing we would normally just call a constant, and there's many times when, unfortunately, we have to do that part of it. Okay, alrighty. Now, next, we have to look at two properties for summations. The first one goes like the following. The summation from I equals 1 to n of c times f of I is going to be equal to, and I'm going to use my eraser because my c doesn't look very nice. I'm going to make it look a little better. There we go. And in this case, what c represents is just any plain old number or constant. Okay? And what's true, what we've seen in the past when we've done summations, is that if we have a constant times a function, so what you do is you'd think of the f of I as being something in terms of a variable, so that would be your regular formula, your regular equation, that sort of thing. But we happen to have a number in front of it. What we're allowed to do is take the constant in front of the summation. All right, so essentially the c, let me choose a different color here. The c, the constant, can just get factored out front. Okay, so that's the first property that we'll use many times. And the second property that we'll also use many times is the following, that the summation from I equals 1 to n for a function called f in terms of I, plus or minus a function called g in terms of I. So here the key to look for is that we have things either added or subtracted together, added or subtracted together. And what our rule for summations of plus or minus says is that this is going to be the summation from I equals 1 to n of the first function, plus or minus the summation from I equals 1 to n of the second function. So if you have the sum of a plus function or the sum of a minus function, we can just take the individual summations. So we start with one summation, we end with 2. And that's, again, a property that we're going to use many times in the next couple of days. Okay? And finally, excuse me, the last bit of review information that we need to work through before we get to kind of some of our more important brand new stuff is that we have some formulas. In fact, let me just start lower. We have some formulas or shortcuts to help us with certain types of summation. So formulas or shortcuts for summations. Okay, there we go. All right, and the reason we've developed formulas or shortcuts for some of our summations is because we can have a problem like the following, which I'll now put up above here. We could have a problem like the following, which would be a lot of work. So if I gave you as an example, the summation from I equals 1 to 40 of 3i squared plus 2i minus 5, boy, this would be a terrific amount of work. Holy Moses. Because this is saying everywhere you see an I, put in 1. Okay, no problem. Plus, then everywhere you see an I, put in 2. But then, holy Moses, we'd have to keep going until the last number you put in would be a 40. And you can see that would just be a huge waste of time or use of time. That'd be a lot of work. So luckily for us, we have some formulas or shortcuts for these summations. All right, and we're going to focus on 4 of them. We're going to focus on 4 of those shortcuts. And just to let you know, or maybe you might remember from pre-calc, there's actually more and more. There's many others actually, but we're going to keep it kind of simple. And here's the 4 shortcuts that we're going to use. The summation from I equals 1 to n for just a constant function. Okay, so we're taking the summation, should kind of familiar. We had one earlier with a 7 in that spot. Okay, but how do we find the summation of just a constant? And the answer is we take the constant multiplied by the value of n. I should mention one thing before I get too frisky with all of these. These rule shortcuts are going to work when, I forgot to choose my highlighter, when the first number that goes in is a 1. If the first number that goes in is anything else, like a 7 or a -8 or even a -1, we have to adjust a little bit. So all of our shortcuts only work when the initial value that goes in is a 1. All right, please keep that in mind. The second shortcut formula, again, we're going to be starting with a 1, and we're going to work up to n, but this time we're just going to be taking the summation of a single variable. And what I'd like you to notice is that the variable in our formula is the same as the variable identified by the sigma, by the summation. Okay? And the shortcut, when this is the case, is going to be whatever the value of the top number on the summation is, n, multiplied by n plus 1 divided by 2. And don't worry, I'll show you how the summation works with some examples. Okay, we've got 2 more shortcuts that we're going to worry about. The third one, the summation from I equals 1 to n of a variable squared, And the shortcut for this one, a little bit tougher, in fact, this is the toughest rule, is going to be the number on the top of the summation, whatever the heck that is, times that number plus 1 times 2 times that number plus 1, all divided by 6. And finally, the fourth and last shortcut formula is going to be when we have the summation from I equals 1 to n of a variable raised to the third power. And when the variable is raised to the third power, the shortcut is going to be the number on the top, n, times that number plus 1 divided by 2. So you might look up, hey, that's the same as the rule for that rule number 2, but we don't stop there. Instead, what we do then is square that result. We square that result. Okay? So those are the 4 shortcut formulas that we have for summations that make our lives a little bit easier when we have a very difficult or time-consuming summation that we're being asked to do. Okay? So just to kind of get a feel for how those are going to help us, I'm going to do relatively quickly here 4 examples for each of those. One for each of those, so totaling 4. So as an example, if I gave you the summation from I equals 1 to 200, and before I give you what the formula is, just think about that. That means we'd start by putting in the number 1, then 2, then 3, then 4, then 5, all the way up to 200. But if what we're taking the summation of is just a simple constant like 4, the first shortcut says if this is just a constant, just a plain old number, then what we do is we take that constant and multiply by the top number, the n. So what we get as a result is 200. So 4 times 200 is 800. In other words, what we'd have is 4 plus 4 plus 4 plus 4 plus 4 plus 4, 200 times, which is the same as 4 times 200. Okay? The second one, if I gave you the summation from I equals 1 to 60 of just a plain old letter, just a single variable, I, again, what this really wants us to do is take 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus ... plus 57 plus 58 plus 59 plus 60. But our shortcut says that this is going to be equal to the top number on the summation, so 60 times 60 plus 1 divided by 2. If my screen would stop jumping around. So therefore, this becomes 60 times 61 divided by 2. And I'm just going to start using my calculator on some of these to make sure I don't mess something up. And what we get is 1,830. Okay? Again, just continuing with some relatively easy ones using all of our shortcuts. The summation from I equals 1 to, 45 for a variable squared. Again, what this actually means is take 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus ... all the way up to 43 squared plus 44 squared plus 45 squared. But our shortcut says we take the top number, that becomes the n value, and what we do is take the top value times the top value plus 1 times 2 times the top number plus 1 divided by 6. And when we do the simplifying, we get 45 times 46 times 91. And when we do that multiplying and dividing, we would get for a total, I hope I punched that out okay, I think I did, 31,395. Right? And finally, the last easy problem using one of our shortcuts would be for a variable cubed. I don't know how big to go because these get really big really fast. How about if I keep this one kind of under control and we just go from 1 to 18. What this actually means is take 1 to the third power plus 2 to the third power plus 3 to the third power plus ... all the way up to 17 to the third power plus 18 to the third power. But our shortcut allows us to just replace the n with 18. So this is then going to be the n value times the n value plus 1 divided by 2 squared. All right, so if I do what's inside first, 18 times 19 divided by 2, I get 171. And then when I square 171, I would then get for a total 29,241. All right, so the shortcuts are meant to act as time savers, all right, for our summations. Now, I need to do one other just because this is going to be very similar to some of the problems we do coming up. But we can also put the shortcut formulas kind of together and use them in conjunction with one another to do a problem then like the following. Find the summation from I equals 1 to, let's go 30 for something like a formula I squared plus 3 times I minus 5. Okay? The idea is now combining multiple rules. First, we have the summation of a plus. We also have minus going on. So technically, one of our properties says that this would then be equal to the summation from I equals 1 to 30 of the first term plus the summation, that's ugly. The summation from I equals 1 to 30 of the second term. But what I'm going to choose to do is factor the 3 out front and then minus the summation from I equals 1 to 30 of the last term, 5. And what we have then is we have a shortcut for this first one. Let me choose a highlighter tool. We have a shortcut for this first one. We have a shortcut for this second term. And we have a shortcut for the third term, right? And here they are. Here they are. For a variable squared, what we do is we take the number on the top. We think of that as being the n. So it'd be the number on the top, 30 times 30 plus 1 times 2 times 30 plus 1. And we divide by 6. Then we're going to add 3 times the summation of a single variable, which is the number on the top, times the number on the top plus 1, divided by 2. And now we just have that extra constant in front. And then finally, we have the summation of a constant, which is the constant times the number on the top, the n value, which is 30. And then we're just going to do 3 individual simplifyings. We have 30 times 31 times 61 divided by 6. So this first one, 9,455. The second one I'll do in blue here. It'd be 30 times 31 divided by 2. But then we have to multiply by the 3 out front. So that'll be 1,395. And then finally subtract 5 times 30, which is 150. And so our overall summation then would be 9,455 plus 1,395 minus 150. And our overall summation then would be 10,700. Okay? So there's a pretty decent, thorough review on summations. There's one other important, very important collection of problems that I'm going to need to do, but since this video is getting so long, I think I'll split it into 2 so I can give you guys a chance to rest, go grab a drink of water or something, and then come back and watch the second one. So this is the first. There'll be a second one that I'll also need you to take a look at, okay? So hope you're having a good day, and we'll see you soon.